Hello everyone, welcome back to Operational Amplifier classes. I am Lavanya Vaishnavi. So this is the third session. I'm going to tell about basic operational amplifier circuits. So in that I'm taking two important basic amplifier circuits which are inverting amplifier and non-inverting amplifier. So inverting amplifier and non-inverting amplifiers are the basic operational circuits. To understand these two, I have to take up one minute topic which is called as virtual ground. So what is virtual ground? After that, first we will understand what is virtual ground, then we will move on to the topic inverting amplifiers and non-inverting amplifiers. Coming to the concept of virtual ground, let us understand what is virtual ground. To understand the virtual ground, I'll take an circuit of inverting amplifier. So this is the circuit of inverting amplifier. Soon after this slide, we will understand what is this inverting amplifier. So for time being, let me assume this is an inverting amplifier, and to understand this, I'll take up the basic property of OpAmp, which says that input impedance of the OpAmp is infinity. If input impedance of the OpAmp is infinity, what will be the parameters that affect the virtual ground? So now we know that Zn is equal to V divided by I, right? Zn is equal to V divided by I, that is applied voltage divided by applied voltage divided by the current. And what is the value of infinity? Infinity is any number divided by 0 is infinity. Now here Zn is equal to infinity, Zn is equal to V by I. So I can equate V by I is equal to infinity. V by I is equal to infinity. So here I am equating it, and what is the value of infinity? Any number divided by 0. So V is nothing but a number. I can say it is a number, but current is completely equal to 0, right? Because current is equal to 0, this relation is equal to infinity. So V I'll take up as it is, divided by 0 is equal to infinity. In the next step, what is the value of V? V is applied voltage. So if this is V1 and this is V2, okay, this is V1 and this is V2. So V is equal to V1 minus V2. The applied voltage at B is V1 and applied voltage at A is V2. Then V1 minus V2 is divided by 0 is equal to infinity. So now let me push the 0 to the right hand side. Infinity into 0 is 0. So V1 minus V2 is equal to 0. So if I take V2 to the other hand side, it becomes V1 equal to V2. What is the value of V1? V1 is grounded. Therefore, V1 equal to V2 means that both the points are grounded. Now V2 is connected to ground. Now V2 is also connected to ground. It means that V2 is virtually grounded. V2 is virtually grounded. So this is about virtual ground concept. It means that if one terminal is at the potential V1, the other terminal is also at the same potential V1 because the input impedance is infinity. This is the concept of virtual ground. Okay. Now coming back to inverting amplifier. Firstly, to write a circuit of inverting amplifier, first I have to write the OpAmp. So OpAmp has 5 terminals. Okay. So this is inverting terminal, non-inverting terminal, plus VCC, minus VEE and output. So I want everyone to take up a pen and paper and start writing with me. Okay, so I'll write an OpAmp. Here this is minus and this is plus, where plus is in non-inverting input, minus is inverting input, and 7 is plus VCC, 3 is minus VCC. I'll connect 2 with the input, right? Because I want the input to be given to inverting amplifier. That point what we are discussing, inverting. So I'll give the input to inverting terminal. So this is R1 connected to Vi. Okay. So here from 2 I'll connect a resistor to 6. So this is RF. This is RF, which is feedback resistor, and 6 is the output, which is V0. Okay. Now 3 is connected to ground. 3 is connected to ground. You don't have any other input to the ground. So 3 is connected to ground. So if you just see this, R1 is the input resistance connected to 2. RF is the feedback connected from 6 to 2. From output to input, you are taking the feedback, right? From output to input, you are taking the feedback. To which terminal you are taking the feedback? You are taking the feedback to negative terminal. So it is a negative feedback. So this offers a negative feedback for inverting amplifier. In most of the cases, we will go for the negative feedback because it has several advantages. And for only few circuits, you are going with positive feedback. Okay. So this is about the circuit. Next is when I take up with the currents, what happens to the currents here? I'm taking currents I1, which current I1 and IF here. So I1 is the current flowing from input to node A, and then it flows through RF and V0. And a small amount of current will be flowing into OpAmp. Now let us understand what is the basic point of OpAmp is. Input impedance of the OpAmp is infinity. Input impedance of the OpAmp is infinity. If the input impedance is infinity, it means that there is no connection at this point, right? There is no connection at all at this point. It means that whatever the current that is flowing through node A towards node A, it will directly deviate to RF and go to the output point. This will be the path of current. So there is no current flowing towards the OpAmp. So this is the property of ideal OpAmp. Now I want to define what is the value of I1. What is the value of I1? As point B is grounded, A is also grounded. Because of the concept of virtual ground, I can tell that if point B is grounded, the point A is also grounded. So I1 can be written as input. See, what is the difference between voltages here? Vin minus Va divided by R1, right? What is the value of Vin? It is Vin only. So it is Vin minus, what is the value of Va? Va is ground. What is the voltage of ground? It is 0 divided by, what is the resistance the current is flowing through? R1. Okay. So I1 is flowing through R1. Therefore, divided by R1. The value of I1 is Vi minus 0 divided by R1. Now, in the same way, I have to write the value of IF. If I want to write the value of IF is equal to, so from where to where the current is flowing? It is flowing from node A to output node. Node A, what is the voltage at node A? It is 0. So 0 minus, what is the output voltage here? Which is V0. V0 divided by RF, through which the current IF is flowing is RF. The resistance through which the current is flowing is RF. So now these are the equations for I1 and IF. So it is V1 by R1. It is minus V0 by RF. Okay. So coming to the analysis part, the same thing I'll take. So I want to find, okay, I want to find what is I1 and I have to find what is IF. So I found out what are the values here, right? So using those same values, I can write it here. IF is equal to minus V0 by RF. I1 is equal to Vi by R1. So if IB equal to 0, these two currents are equal. Okay. So I'm simplifying it. I'm taking V0 by RF, minus V0 by RF, Vi by R1. So here I can move this Vi to the left hand side and RF to the right hand side. Okay. So I got it as V0 by Vi is equal to minus Rf by R1. So what is V0 by Vi? V0 by Vi is the gain. It is the voltage gain of amplifier. So V0 by Vi can be replaced with AV. The gain of the amplifier is Rf divided by R1. If they ask you to find the value of V0, I can write it as V0 is equal to minus Rf divided by R1 into V1. Into Vi. Using this expression, you can find the value of V0. So, what is the importance of negative sign here? What is the importance of negative sign? So, the negative sign indicates you have a phase shift of 180 degrees at the output. You have a phase shift of 180 degrees at the output. So, here I indicate that there is a, if you have a negative sign, it indicates that you have 180 degree phase shift. That is, if you have a sinusoidal signal at the input, you will be getting minus sign signal at the output. So this is the amplified version. Okay, so that we will see it in the waveforms. So what you are having here is, here you have an input which is sinusoidal signal. Here you have positive peak, but at the output you have negative peak. There is a mistake here, like you have to increase the amplitude, which is not shown here. So you have to increase the amplitude like this. So both can't be at the same amplitude. So you can clearly see, if you have positive input, you have negative peak here. If you have negative peak here, you have positive peak here. It means both are phase shifted by an angle of 180 degree. The negative sign in the equation represents 180 degree phase shift at the output. So the next one is non-inverting amplifier. In a non-inverting amplifier, so we retain some part of the circuit. See, R1 is always connected to negative terminal, inverting terminal. Feedback is also always connected to inverting terminal. So R1 and RF are both connected to inverting terminal. Only thing we have changed is, here the ground is given to inverting terminal and input is given to non-inverting terminal. So before, here you had an input, right? Now here you are giving the input. Okay, so the input have been interchanged. Okay, and also the ground was given to B initially, now it is given to A. So this is the circuit of non-inverting amplifier. You will be having plus and minus VCC here. So you have plus 7 here and this is minus 4. So where you give plus VCC, here you are going to give plus VCC, here you are going to give minus VEE. You take the output at pin number 6. A, that is inverting in terminal, is pin number 2, non-inverting input is pin number 3. Again we make the same assumption, telling that input impedance is infinity. If input impedance is infinity, there is no current flow here. That is, current flowing towards the OpAmp, IB, is equal to 0. Because this point is grounded, you can't expect current flow in forward direction. So the current will start flowing from V0. So it will flow through RF, reach the point A, node A, and here, because the input is 0, it will go towards R1 and further move towards ground. Here I want to know what is the value of I1 and what is the value of IF. So to find the value of IF, I'll write IF is equal to, from where to where the IF is moving? IF is moving from V0 to VA. What is the potential at VA? Now look at the potential at VB. At what potential VB is? VB is at the potential Vin. Therefore, VA will also be at the same potential. Even VA will be also at the same potential. So what is the potential at VB? It is Vin. So what is the potential at VA? It is V in. Why? Because of virtual ground. Yes, because of the virtual ground, VA and VB are at the same potential. Now IF is equal to, from where to where the current is flowing? From this point V0 to V in. So V0 minus V in divided by, through which the current IF is flowing? It is flowing through RF. So it is RF. V0 minus V in divided by RF. So IF is equal to V0 minus V in divided by RF. The same way, if I want to calculate what is I1. I1, so look at this, from where to where the current is moving? It is moving from VI to ground. So it is VI minus, ground is 0 divided by R1. Okay. So VI minus 0 divided by R1. So this is the equation for IF and I1. Next, coming to the derivation part, according to virtual ground, the value of V1 is equal to V2 and I1 is equal to IF. So I1 is equal to V1 minus 0 divided by R1, and which is Vi divided by R1, and IF is equal to V0 minus Vi divided by RF. It is nothing but V0 minus Vi divided by RF only. So if you can see this, I have derived the same expressions here, right? So the same thing I have taken here up to this point. Next, we know that the current I1 is equal to IF, right? So I can equate these two expressions. These two expressions I can equate it. So that is what I have done, because I1 is equal to IF, VI divided by R1 is equal to V0 minus VI divided by RF. I'll move this R1 to the other hand and RF to left hand side. So it becomes VI into RF is equal to V0 into R1. So I'm multiplying these terms, okay. So V0 into R1 minus Vi into R1. Because you have Vi and Vi common here, I'll take Vi common here. So if I take Vi common here, it becomes RF plus Ri. Okay. So move this, separate this voltage terms and resistance terms. If I separate them, I get it as V0 by Vi is equal to RF by RF plus R1 divided by R1. So this is nothing but, if I separate the denominator, I'll be getting RF by R1 plus R1 by R1. So R1 and R1 get cancelled. You will be left with 1 plus RF by R1. What is V0 by Vi? It is equal to AV. It is equal to AV. It is equal to AV, which is gain, equal to 1 plus RF by R1. If they ask you to find the equation, or if they ask you to find the output voltage V0, you can calculate V0 is equal to AV into Vi. You can calculate V0 equal to AV into Vi. Okay, what is the value of AV? It is 1 plus RF by R1. Using these expression, you can calculate V0 and also you can calculate the value of gain, voltage gain. Now coming to the waveforms. So look at this, you don't have any inverting or negative sign here. It means that there is no phase shift. So you have, when you give positive pulse, you will be getting positive pulse. You are giving negative pulse, you are getting negative pulse. Only thing is the amplitude has been increased. Look at this, I am covering one box here, like 1 unit. Here I am covering more than 1 unit, increasing the amplitude. It tells that I have amplified the signal. I have amplified the signal. Okay. So if they ask you to write about inverting amplifier, what are all the points you have to write as? So the first thing, you have to write the circuit. Explain the circuit using the derivation, like what are all the different parameters you have, and what are all the different equations you can obtain, that is output equation and gain equation you have to obtain. And finally you have to write what is what is the waveform of inverting and non-inverting amplifier. If they ask you to write about inverting, write the inverting waveform. If they ask you to write about non-inverting, write down the non-inverting waveform. Thank you everyone. Thank you for watching this video. So if you have any doubts, you can revert me back to the mail ID here, and like the video, share the video, and subscribe to my channel. Thank you.